Good day, friends. Welcome back to Smart Book Guide. In today's video, we are going to be solving another problem on Coulomb's law. The problem goes this way. It says 3 point charges, right? Q1, Q2, and Q3, each carrying a charge of 1.5 coulomb, right? So let's bring out the given. So here is the given, right? So Q1 equals Q2, right? Equals Q3 equals the positive 1.5 microcoulomb, right? So let's convert it. It will become 1.5 times 10 to the power of negative 6 coulomb, right? Let's proceed with the question. Then it says these three charges are what? Are located at the vertices of an equilateral triangle, meaning that an equilateral triangle is a triangle with equal sides. So let's say this here is Q1, right? Here is Q2, here is Q3. So they need to form a triangle. Here it is, right? And it also says that these three charges, which is Q1, right? Q2 and Q3, right? They are on the vertices. So the vertices are these points here, isn't it? Then the next thing we need to put into account is that it says with length of 30 centimeter, right? It has a length of what? 30 centimeter. And we need to calculate what the force exerted on Q1 due to Q2 and Q3. So the length, right? Length equals 30 centimeter, same as this, right? 30 centimeter. Here is also what? 30 centimeter. So the question here says we should find the force acting on Q1 due to what? Q2. So the force due to Q2 on Q1 will goes like this. F1, the force on Q1 due to Q2. And the other one, this Q3 on Q1 will go this way, right? That will be what? The force on what? Q1 due to Q3, right? So since this is the graph for it, and we know equilateral triangle have equal triangle, so every side is this triangle is 60 degree each. This side also is 60 degree. Why if we split this side into two, what we end up having here is that there's 30 degree here and there's another 30 degree here, right? Hope the concept is clear. So now what we need to do here is that we need to solve for the force F12, right? Which means our point, the thing we need to solve for first here is to look for what? F12 equals to unknown. Then F13 is also equal to unknown. So if we know F12 and F13, we can find what? The total force, which is the resultant force, right? So we need to start with what? Finding F12. We remember to find a force between 2 point charges. Yeah, we need to use this formula. F12 equals K Q1 Q2 by what? R squared. But remember, R is given to us as L, right? So it's the same as K Q1 Q2, right? Over L squared. And L equals 30 centimeter. So we can convert L, that is 30 centimeter, to meter to become what? 30 times 10 to the power of negative 2 meter. Then the next thing we need to do is to what? To substitute. So F12 equals, we know K is a constant and it has a value of 9 times 10 to the power of 9, right? Times Q1 is having a value of 1.5 times 10 to the power of negative 6 for Q1. Likewise, since they are both the same, 1.5 times 10 to the power of negative 6, all divided by L squared, which is same as what? 30 times 10 to the power of negative 2, all squared. Then we need to keep solving. So F12 equals 9 times 1.5 times 1.5 times 10 to the power of 9 minus 6 divided by, right? This 30 times 10 to the power of -2 will give us 0.3. Then we can now square it, right? So the next thing we need to do here is that 9 times 1.5 times 1.5 will give us a value of 0.2, what? 20.25. Then times 9 minus 6, that's 9 minus 12. 10 to the power of 9 minus 12 divided by what? 0.09. That equates to what? 20.25 times 10 to the power of 9 minus 12 will give us what? A value of minus 3, right? Because 9. So it gives us a value of minus 3 divided by what? 0.09. So therefore, this results in what? 225 times 10 to the power of -3, right? Equals to what? 0.225 Newton. That's what? F12 equals 0.225 Newton. So, yeah, it is. Now, the next one we need to find is what? F13. But F13 is equal to F12 because since Q1, because in this case we are having Q1, Q3 divided by L squared. I know since Q1 and Q3 are all equal, right? Q1, Q2, and Q3 are all equal. Definitely, if we substitute, we end up having the same value. So we just say that this is also equals to what? This. So at the end of the day, we got the value for F12 and F13, right? So the next thing we need to do here is that we need to solve for the component, right? We know the force that is being exerted due to F12 and F13. So we need to find the resultant of these two forces, right? So what we need to do is to find the resultant of these two forces. And how are we going to do that? We have to make a sketch, right? So I know that here is the charge. The force due to Q2 is F12. Due to Q3 is what? F13, right? So here is our y-axis. Here is our x-axis, right? So what we need to do next is that we know this angle is 30 degrees. The angle F13 makes with x-axis because here is Q1, right? Is 30 degrees. Now the angle, right, from this x-axis to F12 is this angle, right? It is 330 degrees. Or we can say the angle it makes through here is what? It's minus 30 degrees, but want it to be what? In positive form. So in that case, the angle between F13 and x-axis is 30 degrees, and the angle between x-axis and F12, right, is what? 330 degrees, right? So we need to resolve this vector to know the resultant value of F. Resultant value of F should be along this side, which is capital F, right? So in that case, we need to do this, right? Solve for the resultant value. So for we to do that, what we need to do is that we say the summation of the x component, right? That's what we need to look for here, which means summation of f of x, right? That has to be equal to what? F13, because the x has to do with cos, it is the x-axis, cosine of theta of 13, right? Plus F12 cos theta 12, right? Let's look at the sketch. We can see that this angle here, which we said is 330 degrees, is what? The theta 12. And theta 13, right, equals 30 degrees, right? So since theta 13 equals 30 degrees and theta 12 equals 330 degrees, and we know the value of F13 equals to F12, which is also equal to 0.225 Newton, right? All we just need to do is to what? To substitute. So we say summation of f of x is equal to what? 0.225 times the cosine of 30 degree, right? Plus 0.225 times the cosine of 330 degree. This results in a value of 0.225 times 0.866 plus 0.225 times 0.866. Then it equals 0.1949 plus 0.1949. By adding these two values together, we get 0.39 Newton. That's the summation of x component is 0.39 Newton. What about that of the y? So we need to say the summation of what? Y component, right? Summation of f of y equals to f of 13 sine of theta 13 plus f of 12 sine of theta 12. So we just need to what? To substitute again the values. So that ends up being what? We have 0.225 sine 30 degree, because the y component has to be on the y-axis, then 0.225 sine 330 degree. This equals 0.225, 0.5, because the sine 30 degree is 0.5 plus 0.225, and this sine of 330 degrees minus 0.25. So everything equals 0.1125. So if you multiply 0.225 times negative value, we end up having negative 0.1125. This equals to 0. In essence, right, the summation of the y component is 0, right? So we can say that summation of f of x equals 0.39, comma, and the summation of the y component is 0. So now to find the resultant value, f, comma, that has to be what? F equals to what? The square root of summation of f of x, you square it, plus the what? Summation of f of y, you square it. So let's substitute. F equals this square root of what? 0.39 squared plus 0, right? So F equals 0.39 squared, right, is same as 0.39 Newton. Therefore, the resultant force is what? 0.39. One more thing we need to look at is the direction, right? The direction of resultant force F, right? So since we already calculated F to be what? 0.39 Newton, right? The direction is what? Tan theta equals the summation of f of y over summation of f of x, which equals 0 over 0.39 equals to 0. Definitely theta, right, equals 0 degree, which means it is directed along x axis, which means what we got is correct. So I hope this problem is demystified and cleared. Then, any other question, feel free to ask. See you. Bye.